So today's topic is about displacement current. First of all, we will discuss what is current. This one. Current is a form of energy produced by charged particles. Flow of charged particles. Flow of electrons. So flow of electrons will produce energy called current. Current is denoted by I and it is measured in amperes. So the measurement of the current in SI system is amperes. We can say just we'll put like this amp. So the current can be produced through the conductor by connecting the conductor to the battery. A source of voltage. A source of voltage produces current. How? I will take a conductor, a long conductor. So this is a long conductor. Here, I'll denote this conductor, ends of the conductor with one is P, and here this is Q. So now this is a conductor just like a copper, nickel, any metal, iron, like that. On this surface, we have the electrons at room temperature also, which move freely on the surface, but not in a particular direction. All the electrons on this conductor move randomly, their direction is not specific. Now they do not produce the current. They do not produce the current. And if you take a circular loop also, so I will take a circular loop. This is the conductor, just like a copper wire in a circular ring form. And this circular ring form, again, it also has free electron on its surface, but the electrons are not flowing in a specific direction. We don't have the current flowing through this one. Once you connect or place this conductor in the circuit, having a battery voltage source, I will connect this to the battery, then pass the current. Current is passed through this conductor. So I will pass the current here in this direction. And even in the circular loop also, I will pass the current here. So current flowing through the conductor or the circular loop is I here. So this current is produced in the conductor by the external voltage source, and this current is constant. Constant current is flowing through the conductor. According to the Ørsted experiment, magnetic field is developed around this conductor. We have the magnetic field around this conductor. Here we have the magnetic field according to Ørsted experiment. Even here also a magnetic field is developed at the center of the circular loop. So this current is due to the flow of electrons from one end to another end. Even in the circular loop also flow of electrons. So this current I is in clockwise direction. No, flow of electrons will be in anti-clockwise direction. So this flow of electrons, constant current produces a magnetic field. Now coming to the magnetic field. How much magnetic field is produced? So this was derived or calculated. We can calculate using Biot-Savart's law and Ampere's law. So now I will take Ampere's law for this loop. According to Ampere's law, so magnetic field developed at the center is integral. This is line integral B dot dl. This much is developed. B is the magnetic field which is developed at the center of the loop, And this is the line integral of magnetic field. So this is the magnetic force, magnetic field, and the line integral force multiplied by length, which is equals to total work done. Total work done by this magnetic force on unit magnetic pole. So this is equal to, according to that is Ampere's law, mu naught I. If it is in vacuum, mu naught I, or if it is any other medium, this is mu I. So this is Ampere's circuital law. This is the work done by magnetic field, magnetic force here. So a constant current produces magnetic field. This is the concept of Ørsted experiment in electromagnetism. And if a constant current is flowing through circular loop, then the total work done by the magnetic force integral B dot dl equals to mu naught times current I here. So this is about the current. This is the ordinary current, flow of electrons, which is constant through the conductor. Now what about the displacement current? What is the difference between a current, constant current, and displacement current here? This displacement current is not produced by flow of electrons. There is no flow of electrons from one end to another end here. Then how this displacement current is produced? So this was observed by Maxwell. Maxwell observed. So this is Maxwell theory. Maxwell theory on displacement current here. How this displacement current is produced? We have to see that one. This displacement current is produced whenever there is a change in electric field. So change in electric field. E is the electric field here. So change in electric field produces current. This current, either in vacuum, it may be in vacuum, or so it may be in any other medium. So the change in electric field may be in vacuum or in any medium. That medium is known as dielectric medium. So this dielectric medium and this vacuum, whenever there is a change either in vacuum or in any dielectric medium in electric field, change in electric field produces current. This current is known as displacement current. So displacement current is this one. Yeah. So there is a difference between displacement current and the constant current. This current, ordinary current, which is produced due to the flow of electrons between the two ends of the conductor in a specific direction, one end to another direction. So if the electrons are flowing from right to left, this is the flow of electrons. All the electrons are flowing from Q to P. Current flows from P to Q in opposite direction. Here. This is done by just connecting a voltage source. And this current is constant. Sometimes we can vary the current by using a rheostat or a variable resistor or a potential divider. So then also the current is fixed here. This is the ordinary current. Ordinary current produces magnetic field. So ordinary current produces magnetic field and displacement current also produces magnetic field. Displacement current also does some work. That work is nothing but which is equal to the work done by the ordinary current. You have to remember, you have to note down 3 points. So number one is the current, which is ordinary current, is due to flow of electrons to the conductor. through the conductor. This is not in vacuum or in any substance. Dielectric substance may be, it is not a conductor. So what the dielectric substance is selected may not be a good conductor of electricity, may not be that is transmitting the current here, allowing the current. So it may be just like a wax paper or a paper, ordinary paper, some gases, liquid or any solid substance. But this current, constant current flows through only the good conductor of electricity. So just like iron, nickel, cobalt, like that. So this ordinary current produces magnetic field, and this magnetic field does some work. The work done by the magnetic field we can calculate using Ampere's law. Integral B dot dl equals to mu naught I in the vacuum. That is, if the conductor is placed in the vacuum, if the conductor is placed in any other medium like a liquid dielectric medium or a gaseous medium, this is mu. Mu value is the permeability of that substance where this conductor is placed. It changes from substance to substance. And what about this displacement current? So the displacement current does not require any conductor like this copper wire, iron wire. So it can be produced in vacuum or in any dielectric medium. When? How? When there is a change in the electric field. As per the Maxwell theory, when electromagnetic radiation like sunlight propagating through vacuum or in any substance, this substance is called dielectric substance, just like a as I told, any type of substance may not be a good conductor of electricity. If there is a change in electric field, if there is a divergence, we can say in vectors notation, when there is a divergence in electric field, current is produced, that current is called displacement current. Okay, to understand the displacement current here, so I'll give you an example of capacitor. Capacitor, so we will take an example for that one is capacitor. Plates. So these capacitor plates are arranged at a distance and in vacuum or in any other dielectric medium. So we can keep these two plates of the capacitor in vacuum in any other dielectric medium. Now I will take one capacitor plate. This is one capacitor plate and this is the second capacitor plate. And we will have a positive charge to one plate. So this is the positive plate. This is plus Q charge on that plate and equal charge here, but it has excess electrons minus Q. These are the two plates of the capacitor. This is an example how change in electric field produces current. Now this is the gap between two plates of the condenser. This gap may be filled with a substance, as I said, any gaseous substance or a liquid substance, or you can plate a sheet, wax, a paper or something sheet, plastic sheet, dielectric sheet, whatever it may be here. So that substance which is used to place in between the two plates of the capacitor is called dielectric medium. So here we can keep either vacuum, here this gap. So that gap is filled with vacuum or any dielectric substance. So we can place them in vacuum or in any dielectric substance. So now you have the vacuum space or dielectric space. Now we want to observe how electric field can be changed in this vacuum. This is the gap between two plates of the vacuum here. So this gap can be filled with either vacuum or dielectric. We have to change the electric field. Once you place this positive plate and a negative plate in the vacuum at a distance, this is the distance between the two plates. Here, this is the distance here. And we denote this distance with D. We can change the distance also, distance between two plates of the capacitor. So the two capacitors are placed, one is positive and another is negative. Two opposite charges are placed at a distance in vacuum and dielectric or dielectric. Electric field is produced. Here we have electric field between these two here. Between these two, we have the electric field. Because this is positive plate and this is negative plate, two charges are placed at a distance and they produce electric field. Now, what is the use of this capacitor? This capacitor is used to store the charges, electric charges. We can use these capacitors in electric motors like a fan motor or a pump, water pump motors like that, or inverters. So we can use them to store the charges, electric energy. So what you have to do here, even in our mobiles also, we have the capacitors in the chargers. So what you have to do, you have to charge the battery. When you done one, you have to increase the charge on one plate. So you have to increase the charge on one plate. So this charge is the excess charge which is settled on this plate. It is transferred to the second plate. So this is the transfer of this excess charge which is given to the positive plate. As the second plate is negative, it is transferred onto the second plate. It means this charge is moving in between these two plates. Then electric field depends upon the charge. So electric field formula is F equals to 1 divided by 4 pi epsilon. Epsilon is the permittivity. If it is the space, epsilon naught. If it is the dielectric medium, epsilon only. Q charge divided by distance between the two plates, d square. We are increasing the charge on one plate, so charge Q is increased. Obviously, electric field is increased. There is a change in the electric field. So this electric field produces current. The current produced by change in electric field is displacement current. How much current is produced? We have to see that one. So I will write the formula for electric field between the two plates of the capacitor. This is the parallel plate capacitor. These two plates have area. Area of the plate, each plate is equal. So this one, intensity of electric field depends upon area of the plate and the charge. So this electric field E, this is equals to Q charge. Charge given to the plate divided by A, area of the plate, multiplied by epsilon naught. This one here. Now, so if you increase Q, E also increased. How much change is occurred in E? How much change that you can observe in E? As it is a three-dimensional, so the E is the vector. So vector differentiation, we have to do that one. So we use the vector notation. So when the vector in three-dimensional space is changed, this is nothing but divergence. So change in the electric field is divergence. So I will note down this as a vector. So with an arrow mark above that one as it is a vector. So this equals to del dot E equals to divergence of electric field, change in the electric field, A area of the field, epsilon naught is constant. So both are constants here. A epsilon naught are constant. I'll write like this here. And this is Q. This is differentiated with respect to T. So I will write it as a dou E by dou T. We can write like that one. So I will write like this. This may be dou E by dou T. Instead of taking the divergence, first I will take dou E by dou T, then we will take the divergence. So this is Q. Q is changed, so dou Q divided by dou T. This is the current which is produced due to the change in electric field. So change in that is the charge per unit time. This is current. I will note down this as here. So I will write here. So this is taken here. I will note down as dou E by dou T equals to 1 by A epsilon naught into I. So this is the current produced due to the change in electric field. I current divided by A surface area. So this is current density. This is current density. So I can write this as dou E by dou T equals to current density, which is equals to displacement current T. So this is by epsilon naught. So this D is called displacement current. So now I will write this D equals to epsilon naught dou E by dou T. Displacement current is the current produced per unit surface area when there is a change in the electric field. So this is about the displacement current. So this is not produced due to the external voltage supply. This is due to the change in electric field in vacuum or dielectric medium. This displacement current has a significant role in electromagnetic theory, electromagnetic waves according to Maxwell theory. So we will discuss that in the next class.